Hello, and welcome back to the John Louis Memory School. Get ready for a lesson so fun you won't even realize you're learning. Today, we are diving deep into the magical chemical world of turning plain old rocks into treasure. Let's do this.
All right, Memory Mavericks, I have a question for you. You're holding a rock, right? And you know there's gold in there, but how do you get it out? Today, we're going to learn the secret to transforming boring old rocks into pure, shimmering treasure.
So what is this incredible secret? Is it an ancient spell, a secret handshake? Nope. It's a truly magical sounding process called leaching. And trust me, by the time we're done, that word is going to be stuck in your brain forever.
Okay, so let's get into the nitty-gritty. It all comes down to a special kind of, well, a magic melting metal juice. So what is this stuff and how in the world does it work?
Okay, here's the official super sciencey definition. Don't worry, we're going to make it easy. Hydrometallurgical, whoa, big word. All that means is we're using a liquid to get our metal. But the real magic words here are selectively dissolving. That is the key to everything.
The whole trick, the entire secret behind the curtain, is this one simple principle: selective solubility. It basically means our magic juice is a super picky eater. It's not interested in the whole rock. It only wants to gobble up the good stuff.
In fact, you can think of it as a simple 3-step magic trick. Step 1, you pour our special liquid, it's called a lixiviant, all over the crushed up ore. Step 2, that lixiviant gets to work dissolving only the valuable metal you're after. And for the final reveal, step 3, all the useless junk rock is just left behind. Ta-da! Now here is the absolute best way to remember this. Picture a toddler with a plate of food. On that plate, you've got a delicious, yummy cookie, that's our valuable metal. And you've got some yucky broccoli, that's the useless rock. What does the toddler do? They eat the cookie and leave the broccoli. That's it. The cookie is soluble, the broccoli is insoluble. Simple as that.
All right, so that magic liquid has a fancy name, lixiviant. But don't you worry, our very own memory grandmaster John Lewis has a tip for us. Just imagine the liquid saying, I will lick this if I want to. It only licks up what it wants. Get it? The licks if I wantient.
And what about that leftover yucky broccoli, rock? Well, that's called the gang. And to remember that, just think of it as a gang of useless minerals that are crashing your party. You gotta kick them out. They're the rock gangsters.
So, after our lixiviant has eaten all the cookies, what do you have? You have a liquid that's totally loaded with treasure. And scientists, bless their hearts, have a hilarious name for it, the pregnant leach solution. Why? Because it's pregnant with precious metal. For a quick memory tip, just think PLS. It's your precious liquid stash. Okay, so we get the idea now, but you can't use it everywhere. So when does leaching put on its cape and come to the rescue? Let's look at the specific times when this process is a total hero.
Leaching basically has 3 major superpowers. First, it's amazing for low-grade ores. That's when you have just a tiny, tiny bit of metal hidden in a mountain of those pesky gangsters. Second, it's perfect for soluble ores, when the chemistry is just right and the metal is begging to be dissolved. And third, it's often way better for the environment. It uses less energy and makes a lot less air pollution than its big, fiery cousin, smelting. So you've decided leaching is the way to go. Excellent choice. But, which kind do you want? It's not a one-size-fits-all deal. Welcome, my friend, to the Leaching Methods menu. What can I get for you today? First up on our menu, we have heap leaching. I like to call this the lazy river method. You just pile up your crushed ore into a giant heap, then you trickle the lixiviant over the top. It just slowly, lazily seeps all the way through, collecting treasure as it goes. Ah, so relaxing. Our next option is for the more daring among us, in situ leaching. This is the underground heist method. Get this. Instead of digging the rock up, you pump the magic juice directly into the ground. It dissolves the treasure right there, and then you just pump the pregnant leach solution back to the surface. It's so clever. It's sneaky. It's a heist. And for our final special of the day, we have that leaching, or as I prefer to call it, the heavy metal jacuzzi. You grind the ore into a super fine powder, dump it into a giant tank with the lixiviants, and then you mix it all up. Woohoo! It's a bubbly jacuzzi party for rocks and chemicals. Now, of course, the secret ingredient is picking the right magic juice from our chemical cookbook. For gold and silver, you often use cyanide. Just wave goodbye and say, sayonara, gold. For copper and zinc, you'll want some acid. Just remember, acid is A+ for oxides. For aluminium, you use alkali. That one's easy. A for A, alkali for aluminium. And finally, for nickel and cobalt, you use smelly ammonia. Ew, don't get that stuff on your nicotine patch. Wow, okay, that was a lot of new words, but I know you got this. Let's do a super fast rapid-fire recall quiz to lock it all into our brains. Are you ready? Question number 1. What do we call that useless, leftover rock? The stuff we want to get rid of. Come on, you know this.
It's the gang you. That's right. Get out of here, you rock gangsters.
Okay, question 2. What's that super funny name for the liquid that's now carrying all of our treasure? Think about it. It's full of metal. Yes, the pregnant leach solution, our PLS, our precious liquid stash. You guys are geniuses. And class dismissed. You are now all experts in the magic of leaching. It's an amazing technique that lets us get treasure in a really clever and often cleaner way. A huge thank you to Memory Grandmaster John Louis for all his incredible tips today. But before you go, I have some homework for you. We said leaching is better for the air than smelting, but it does create liquid waste. So my question is, which environmental problem do you think is harder to solve? Air pollution or water pollution? There's no right answer. Drop your thoughts in the comments below. Thanks for coming to the John Louis Memory School, and we'll see you for the next lesson.